Hello to our grade 11 Mindsetters. My name is Tara and I'm so excited to be with you guys here today. We have got so much in store for you and a lot of questions and a lot of competitions going on and about. So let me get started with the one that we have currently. What's happening is that there's a Get Connected competition. And we've posted the link on our Facebook page, facebook.com/learnextra, where you can follow a link that takes you to a Curio page where you must like your favorite teacher from Learn Extra. Anyone that you particularly like or enjoy and you feel really teaches you fantastically. After you've done that, you come back to our page to the same post where you will see links next to all the names of the teachers. And then you must take that link and share it and like it and get as many likes as you can, because the more likes you get, the more points you get in this competition and the more likely your teacher is to win, who, as I believe, will also get a prize which is absolutely awesome. Your prize for this competition, if winning, would be to win a Sony Xperia cell phone and or airtime, which is an absolutely incredible prize to win. So all the information is on our page. You can see everything that you need there. And definitely try get as many likes as you can, because it'll be very beneficial for you and your teacher. Hello, John. Sorry for not introducing you earlier.
No,
How
it's
are
no
you
problem.
today?
We're having a little technical glitch here. So we've got sorted out now. We're ready. Grade 11's great to be with you again today. And we're coming to the last section of grade 11. But I want to link it to some of the work that we did last week when we spoke about redox chemistry. And so I'm really looking forward to this lesson on chemistry.
Me too. I absolutely love chemistry and I love the redox reactions. They're so interesting and they make so much sense. It's wonderful.
Yeah,
So
absolutely.
let's get going. Thank you, John.
Okay, so guys, today we're taking a practical application of redox. Remember last week we did all the theory bits about what's an oxidizing agent, what's a reducing agent, when is something oxidized, when is it reduced, and we looked at assigning oxidation numbers and looking at some common reactions. Today, the challenge is a little bit further. We're going to take a look at the chemistry of mining. And this is the last section of your grade 11 work. It's may be given to you in class as a bit of a project work, but it could come up at the end of your year exam. So I thought that we could just do a little bit of revision while we're looking at the chemistry of mining as well, get some basics in place, and also touch on some other important chemistry principles as we go through this. So what we're going to do is we're going to summarize for ourselves the process of mining. And you'll be surprised, maybe not surprised, that lots of mining is quite similar. Then we're going to take a look at some of the chemical processes involved in the recovery and purification of different metals. So that's our brief. It is a huge brief. There is a mountain of stuff that you could learn, and that's what's made this new curriculum really quite nice, because you only need to do certain parts. You don't have to do it all. So if we think about the mining that you could have been asked on, there's gold, there's platinum, there's copper, there's manganese, there's iron, there's phosphates. All of those have multiple processes. There's coal even. There's other stuff that is used for energy. This all form part of the original things, and you might find them even mentioned in your textbook. But it's very clear, as far as CAPS is concerned, that you only need to do one. The one that is mostly concentrated on, both in the exemplar documents as well as some of the other examples that we've got from provincial exams from last year, is the gold mining sector. So we're going to spend a little bit of time on gold mining particularly. Why not? Because gold, like diamonds, are precious. And we know that South Africa has its economy originally built on gold. Diamonds to a certain extent as well. And we need to understand that our economy is changing. Mining is no longer as big a thing as it used to be, but it's still very important. And we need to understand that it also provides employment opportunities for quite a big group of people. And so we can't ignore it. Right, let's go to the challenge question. Not talking about gold, but talking about something that's also important, talking about iron. And it tells us that iron is extracted from its ore in a blast furnace, And we said that in one of the chemical reactions taking place in the blast furnace, iron oxide reacts with carbon monoxide, poisonous gas that we know isn't very helpful. But here it is, because there's the balanced equation helping us extract iron. And we're asked ourselves the question, what type of reaction is this? And secondly, we're asked, very important question, if a 0.752 kilogram sample of ore produces only 365 grams of iron, what is the percentage purity of the ore? And I think that what's important here, we're asking in terms of this substance being as the ore. So the percentage purity of iron to oxide. So please don't work out percentage purity of iron, because that's too easy. It would just be 365 out of 0.72 kilograms, 52 kilograms. No, we're not wanting that. We're wanting the percentage purity, this percentage purity of the iron oxide. So there might be other things like sulfates and silicates all bundled into this rock. And we want to get rid of that and say, how much iron oxide is there? Because that's where we're starting from. So as a percentage of iron oxide, please work that out. And we'll give you some time during the challenge question. And if you understand the theory, you can just start working on this even now. It's posted on the page.
It is.
Okay. It's got from my computer to Tara's computer without any problem. So guys, where do we start? When we're talking about the chemistry of mining, we have to understand what this word, the lithosphere, is all about. Now, you might remember from grade 10 that there's a thing called a biosphere, which is made up of the atmosphere and the hydrosphere and the lithosphere. Those all work together in an amazing way to provide conditions that support life on Earth. Without these conditions, life wouldn't exist as it is today. It might exist in another form, but we have no evidence so far with all our exploration, when conditions are different to what they are here on Earth, that life can actually exist. So I know NASA spent millions and billions of dollars exploring far reaches of space, and we've even got the Explorer, the rovers on Mars at the moment, and we're not finding much evidence for life on Mars. There might even be a little bit of water, but we know that without water, certainly life in the form that we know it cannot exist. So what is the lithosphere? Without the lithosphere, we can't have life. We need to understand it's as vital to have the lithosphere as it is to have the atmosphere and the hydrosphere. Hydrosphere, the part of the biosphere that has water in it. The atmosphere, the part of the biosphere that has these gases that allow us to breathe. And we know that it's only a very small amount of that atmosphere that is actually oxygen, about just over 20%, between 20 and 30% of our atmosphere is oxygen. And that helps us retain life. It hasn't always been like that, but let's not get distracted. So what is the lithosphere? Now, the lithosphere, if we had to take a look, and I don't know if you can see it because this diagram is a little bit small, but if we had to imagine that that circle there represents the Earth, then the inner bit right down there is kind of the core, and then we get an inner core, we get an outer core, and then we get a whole lot of other stuff that's happening here. It'd probably be a good idea if you did have a look at this on the notes. But you'll see that it's really drawn to scale, that the very outside crust, that very outside region, that's almost just a line, that's sitting on the surface of the Earth. In that is this thing called the lithosphere. And so it's the rocky bed on which we have our homes, our terrestrial homes. And even under the ocean, the lithosphere is there. It's the seabed. it's the support that keeps everything together. Now we know that from geology, those are made up of plates, and the continents have, over time, it appears that there's evidence that they've moved, but they've still formed this outer layer on which plants can grow, and animals can live and walk and reproduce and carry on their functions. Without it, we wouldn't exist. Okay, so it's important to understand. So why are we dealing with this? This is not life science lesson. We're interested in the stuff that makes up the lithosphere. So we need to understand that within this lithosphere, it's mainly made up of elements that have a variety of elements depending on where they are. There's a lot of silicon or silica. Silicon, sand is made up of silica, and that is one of the main elements. But there are other elements that are metals that also are found in the bed of the lithosphere, including aluminium, including iron. And these things are very popular, and there are lots of them. Different distributions. And then, of course, there are the less common elements, things like gold and platinum, and even things that we don't even know. Periodic tables of the higher elemental numbers, like palladium and even lead and uranium. Those are all found in this lithosphere. And of course, man, over the time that he's been around, people have been around, have not been able to find ways to extract valuable tools or extract these elements to make tools and things to make our lives easier. So if we go back in time, we'd recognize that humankind, men and women, have had a role in taking rocks and making tools out of them, using things to craft, to make pretty designs. And they've experimented with them. And so there's been a whole process, and some of that knowledge has been lost. People worked out, even in this part of the world, in southern Africa, how to extract out of rocks elements like copper, and how to extract gold, how to find gold. Now, this didn't need Western influence. African people did mining even before Westerners arrived. So we need to understand that there's a rich heritage, a rich culture in taking out from the soil and making things that are useful to help us survive. And so we need to choose the right tool for the right job as well. So we don't just choose something because it looks good or because we can do it. It needs to function properly. And so that's the field of mining technology, geology, metallurgy, and it's a really exciting field because today there are faculties that are set up at universities where they are looking at making these elements combine into better, more useful materials. And so I would recommend, if you have any interest in this, please go and research it further. Okay, so that's the lithosphere. And men, as I said, have extracted elements from the lithosphere. Men and women have extracted elements from the lithosphere to make tools. What's the process? Broad principle process. There are 3 steps. The first thing is we've got to go and collect the ore from the rock. So this happens depending on where we are. It could happen, ore is just a name for pieces of rock that contain certain elements that we were wanting. So it might be a compound in a rock, and we want to get the element out of that. With gold is a very unreactive element. And so it formed here on the Witwatersrand, in the Witwatersrand Basin, as a conglomerate. It was found in streams, and so it's mixed together with sludge, but there are little nuggets and seams of gold. But in between it, there's a whole lot of other nonsense that's created in it. So we're going to have to get the ore from the rock. So we can either drill down, break up the rock, crush it into small bits. And the next part is getting the metal from the ore. This part, getting the metal from the ore, is usually a chemical process. either by heating or electrolysis or by chemical dissolution, and a series of processes. And then the last thing is purifying the metal. So those 3 steps are crucial for all mining processes. Unfortunately, we can't go into too much more detail, but I recommend you get the notes so you can read up on all the processes. Depending on what metal we're doing, we'll do a different process. Tara, let's go for a break.
Okay, wonderful. Just before we go to the break, I have an awesome competition to tell you guys about, because I know all of you here today with us are Sparks, right? And all of you here with us are grade 11. So this is a wonderful combination for this competition that we've got going. It's called Be a Bright Spark. And what it is by purchasing this K53 Safeways book in preparation of your learner's test, using this receipt or downloading the K53 Safeways Android app from the Samsung Galaxy App Store or the Google
The Google
Play Store, sorry. Then, using that information that you get from your receipt or from downloading the app, you can enter a competition by going onto the link on our Facebook page. And entering this competition, entering all your details, enters you into a competition to stand a chance to win a Chevy Spark car.
Amazing, hey?
Wonderful. It's such a great opportunity while you're preparing for your learners, because a lot of you are in that stage now, just before matric. You might as well win a car. So get onto that. It's not very difficult, but it's definitely a very useful book and a very useful way of getting around to in preparation for those tests.
And in addition, guys, don't forget, we're here to support you and to help you with that. Between the end of this show and the beginning of the grade 12 show, we'll be going through a feature of what you need to know for your, not your learner's test, but your K53 exam. So you can start to see exactly what is going to happen in your exam. Knowing the detail of what's going to happen in an exam often prepares you better than having to practice and fail and so on. So watch the insert between this show and the grade 12 show, or after the grade 12 show.
Definitely, it will be very useful, and we hope that we can help you to the best of our ability. But now let's take a break and we'll see you straight afterwards. Welcome back, Mindsetters. I hope that you're ready for some more wonderful chemistry. I know I am. Before we get to that, I want to let you know that I've posted all the links where you can download what we've covered today in this lesson on our Facebook page, as well as if you just want to view it. But what's there too is a test yourself link. And if you click on that, it'll take you to the career page where you can enter a password and test yourself. See where you are, see what you don't understand, as well as, and once you've submitted that, it gives you wonderful feedback as to where you are, what you got wrong, so that you can get a bit of a better understanding. But what that does too is that it enters you into a competition to win a Casio calculator, and definitely very useful for subjects like these. So I find you must definitely enter and see where you are, but as well as standing a chance to get an awesome Casio calculator.
Thanks, Tara. Let's get going with our chemistry of mining. And as I said, we're going to start with the gold industry, and we're going to see how far we get with this. So have a look at question number 1. It tells us that, as I was mentioning, that gold was mined from as early as 1200 AD in South Africa. Today, South Africa is a world leader in mining and processing of gold. And there are innovations and schemes that we're coming up with all the time. Great mining technology happening in this part of the world. It's been exported to other parts of the world too. It tells us that we should follow the flow diagram that illustrates some of the most important steps in the mining and processing of gold. So where we start with is we start with gold-bearing ore, and we see that after a while there's a process, A, that gives us this funny substance, NaAuCN2. We'll talk about that. And then there's a process B, and then we go to a gold precipitate, and then we go to process C, and we get pure gold. And what it now asks us to do is to identify the process which takes place at C. So what we need to recognize is that once you've precipitated gold, you skim it off, it's down at the bottom, it's a bit of a sludge. What are you going to do to get it into a malleable form, into a form that we know what it's like? So there are two processes that are involved here. The first one is you want to drive off any of the excess fluid, any of the solution that's remaining. So it's a heating process, and it's sometimes referred to as sintering. And when we really want to purify it, we can also do, depends on the purity that it's a refining process. It's heating it up and getting all the gunk off it. And this is an old technique of heating up the gold to a liquid and then pouring it and then heating it up again, skimming off the impurity. And there's the story in the older days, it's almost biblical, of somebody doing this with silver and with gold, heating it up until you can see a reflection in it, and then skimming off the impurities and being left with the pure stuff. Now, today, we also use a process of electrolysis to purify some precious metals, and we even use it for gold. So we really want to get not just 98% pure gold, but 99%, 100% pure gold. We would take a pure gold bar, and we would electrolyze it, put it with the impure substance, put it into a solution, pass an electric current through it, and we would eventually get pure gold precipitating onto the electrode. But for our purposes, it's a heating process that takes place. So give the name or formula of the chemical substance that was used at B originally. So let's have a look at B. So to get this substance, how did we get from the gold-bearing ore to make this solution? Now, as I've mentioned to you earlier in our sort of introductory bit, gold exists in nature as an element. It's been panned in rivers. People not only found it by digging into rocks and seeing these wonderful orange-yellow seams of gold, but they found it in rivers, panning it, seeing little traces, sparkles of gold out of the beds of rivers. It is an element that is incredibly tough, and it doesn't react with too many other things. So it is found in its elemental form. And so when we're looking at gold, comparing it to other metals, if we leave gold out in the atmosphere and expose it, it doesn't develop an oxide. It doesn't rust like iron or aluminium. It doesn't develop an oxide layer. Gold stays pure as its element, and that's what gives its value. So how do we get from this gold-bearing ore, where it's surrounded little bits of gold, tiny fractions of it? That's why we've got to dissolve it. But what does the dissolving? And the stuff that we generally use is something called sodium cyanide. So we are asked to write down the name or the formula, and I'm going to write down the formula as sodium cyanide, like that. Okay? Na for sodium and Cn for cyanide. Cyanide is a combination. It's a radical polyatomic ion made from carbon and nitrogen, and it has a valency of 1. So sodium cyanide, just like we've written it there. If you wanted to write the word sodium cyanide. At some stages, people have experimented and used potassium cyanide, but generally the common one that you'll find in textbooks is the sodium cyanide. Okay, so which chemical substance is now preferred at B, and why is the substance preferred? Okay, so here we go to this process. Traditionally, and the one that you'll find in your textbooks, is by adding zinc to the solution of sodium gold cyanide, you can precipitate the gold, because zinc is a more reactive metal than the gold. But South Africa, as I said to you, leads the way in technology relating to gold. And so instead of using zinc, B is no longer zinc, but what we use is something called activated charcoal, or activated charcoal, or carbon. And what this carbon, it's like a sponge, okay? You pour the gold solution through it, but the sponge is almost it's got special properties that the gold sticks to. It's a bit like separating iron filings from sulfur using a magnet. The activated charcoal, it's not magnetic. Please don't get me wrong here. But it's similar to that idea. The gold sticks to it, and everything else washes through. Isn't that amazing? It's obviously a lot cheaper than using the zinc, and it's a more efficient process. The absorption, because what happens is the gold sits on the charcoal, and we say that it is absorbed onto that surface, and then we are able to wash off the gold with different solvent and get your gold forming out. So the activated charcoal is a very important thing. And why is it? Because it's more efficient and it's more cost effective. Right, the next part of the question asks us, the recovery of gold through cyanidation process has positively and negatively effects. Give one negative effect of the use of cyanide. Well, cyanide is poisonous. And so gold mining and the processing of the recovery of gold has been a bit controversial, because we know that there are even mines now that have an impact on the environment. Fortunately, this is an area that we are now working on, and the engineers involved in mining work very hard to make sure that the impact of gold mining is neutralized and minimized. But in the past, since the beginning of mining history, it hasn't always been the case. And so there has been a negative impact, and that's why we're left with problems like acid mine drainage. And we're left with problems of mine dumps that are excreting and releasing radioactive toxic waste into the atmosphere, although it's not on a very big scale. But all of those processes form challenges for us to solve. So we need to take note that cyanide is poisonous. Cyanide, it's a poison, and it poisons the environment. So the water that is used in dams can also affect the fish and the aquatic life in the dams, and so it has a negative effect. Just by the way, the positive process is that it's a unique process. Gold is very resistant to other substances and to being dissolved in other substances. And so this is an effective way of doing it. And then we're going to go to the last question, which is, after this section, is to give one reason why gold is important to our country. Well, obviously, it provides jobs, although that number of jobs is decreasing, but it also provides foreign exchange. And that's probably the most important, because we can take our gold, and we really are being encouraged to do that, change it into something like jewelry, and then sell it overseas and earn dollars to bring back into the country. That last step hasn't happened effectively in this country for many years. And it's something that is starting to happen, and so it's called beneficiation. Taking our raw materials and just giving it to another country to create their own income is not the way to go forward. The example has often been cited of Thailand, which has no gold reserves, but actually earns a huge amount of foreign exchange because of their jewelry industry. And so we need to promote jobs, create more jobs, not just around the gold mining industry, but around other mining industries where beneficiation takes place. Okay, question number 2 gets into a little bit more chemistry. And I would really like to get to this question because I think it's really important. So question 2, still the similar process, but we're now focusing on from the gold-bearing ore into the dissolution process where sodium cyanide is being used to do that. And it tells us that this process happens, and we know there's the sodium cyanide, and look what else is being added. Oxygen and water, and the whole slush is mixed up, and we get our sodium gold cyanide solution and some sodium hydroxide being produced as a byproduct. So the first thing they ask us to do is to balance the equation. Now, guys, you're in grade 11, but that doesn't mean you don't need to know how to balance equations. I want to take you through this one and make sure that you remember the principles. Not being able to balance this one is that important, but what do we do when we balance equations? So the first thing we're going to do, and I'm going to try and write it on one line rather than on 2 lines, like it's written here, and I might just leave out the phases, so I hope you don't mind that. But just to fit everything in on one line, tells us there are some balancing coefficients in, but not all of them. And the last bit we've got is 4NaOH. So guys, when you've got an equation like this, and it's a long equation, we need to balance it carefully. Let's go for it. The first thing we're going to do is we're going to count up the number of gold atoms on each side of the equation. And I hope you can see there's gold, Au, and there's gold there. But you need to recognize there's 4 of those. So we'd say there are 4 atoms of gold. There's only one. So I'm going to tentatively put a 4 over there. It seems to make sense. Then the next part, I recognize here I've got sodium, and I've got 4 sodiums in front, and I've got 4 times 2 carbons, and I'm starting to see that there is an issue here of 2 carbons times, that's 8. I hope you're seeing that there are 8 of those, and look carefully. I almost fell into a trap. There is 4 sodiums here, and there's 4 sodiums. So if we're going to recognize 4 sodiums plus 4 sodiums, and there are 2 carbons, because we're multiplying there, times that 2 by 4, that means there are 8 carbons. So it seems to me that an 8 over there makes sense. Let me go over that again. 4 sodiums here, 4 sodiums there, means I've got to have 8 sodiums on that side. Got it? Make sure you have. Now, let's check the carbons. We've got 8 carbons on this side. Now, look at this. There are 2 carbons because of that, and 2 times 4 is 8, so we're fine with the carbons. What about the nitrogens? 4 times 2 is 8, and we've got nitrogen. Haven't got nitrogen anywhere else, haven't got nitrogen anywhere else. So, what's the next one? Over here, we've got oxygen. There are 2 oxygens. There's no oxygen there. So let's look at how many oxygens are here. There are only 4 of them, so I need a 2 in front there. Oh, hold on. No, I've made a mistake. Be careful. I've got 2 oxygens over here, and I've got 2 oxygens over there. That means I've got a total of 4 oxygens in both of those. Must look in both the things. 4 oxygens over here. So the oxygens are balanced.
Yes.
Agree?
Yeah.
Okay. So there we go. Let's look at the next thing. What about the hydrogens? How many hydrogens have we got over here? We've got 4 hydrogens. 4 hydrogens on this side. What's that saying? 4 times 1 is 4. So the equation is balanced simply by putting those balancing coefficients in front. But guys, you've got to practice that. Make sure that you get it right for as many things as you can. Now, write down the name of the process labeled A. Well, that's cyanidation. I'm not even going to put that in. Write down the type of reaction that takes place during process A and explain your answer. I wanted to get to this question. I want you to have a look at it carefully. What type of reaction is taking place? Can you explain it? I think it's something that you should be thinking about during the break. So I'm going to hand over to Tara and ask you to think about what type of reaction there is and see if you can answer that question with some explanation. Okay, Tara, take it away.
Definitely. So have a good think about that during the break. Before we go, though, I want to tell you about this awesome event that's taking place this weekend, the 25th and the 26th of October, Saturday and Sunday. It's hosted by Shell at the Kyalami racetrack, and it's called the Shell Ecomarathon. And it sounds absolutely awesome. So what happens is that Shell is now challenging students all over the country to create and develop and build, as well as test, their own fuel efficient or energy efficient vehicles, which sounds incredible. I mean, here we are telling you to enter competitions to win a car, but I feel that some of you will go there with your own creative ideas to make energy efficient vehicles, which is absolutely incredible that the youth can come up with this kind of stuff. This is the future, in my opinion.
Absolutely, and we need it because we need to save the environment.
Definitely. So bear that in mind. It sounds like an amazing event.
And entry is free?
Entry is free, so don't worry about that. But yeah, that's what I wanted to tell you. So enjoy your break, and we'll see you straight afterwards. Welcome back, grade 11s. We're here to do some more chemistry and to finish it off for today. But before we do, revision starts for you guys next week, because I'm sure a lot of you have been concerned as to when it's going to be starting. For you guys, having heard that matrics were busy with summer school, spring school, whatever time of year it is, and now it's time for you guys to get that same beneficial revision. We've moved you up so that you're a little bit earlier on Monday at 6. Sorry, later, Monday at 6. So don't miss out on it. It's now your opportunity to get in some good revision for yourselves before and in preparation for the exams. So definitely tune in next week, Monday at 6.
And of course, on Tuesday will be science. So don't make a date. We'll be starting. Grade 10s move up to the grade 11 slots. Grade 11. Hey guys, we're just giving you a heads up. You're going into your new slots for 2015. So
how exciting.
Yeah, it's like you've passed already because you're watching Learn Extra. Okay, so let's get back to this question. Remember I asked you what type of reaction is taking place in gold, the gold process of A, and let's see. Any answers on Facebook? Anybody comment?
Let me just, no, there isn't.
Okay, no problem. Let's have a look. I'm sure that we're going to look at the equation and say, well, could it be an acid-base reaction? I don't see any acids. And I don't see any bases. Remember, the definition of an acid-acidic reaction is where something donates a hydrogen ion. So I don't see anything with the water. Maybe you could think that the water has changed from H2O to OH minus. Maybe that's a possibility. Maybe you're thinking that. So there might be a reason for you saying that, but I don't think that that's the main reaction. Is it a displacement reaction of some form? Well, if we take a look at it, the sodium and the gold aren't changing position. It's not a synthesis. It's not an addition reaction where you've got these different reagents all making the same product. It's not an elimination reaction. We're not pulling things apart. It's not a substitution reaction. Hi guys, what did we do last week? Redox. So let's go and have a look and see if it's a redox reaction. So how are you going to tell if something's a redox reaction? A change in the number of electrons. Cyan electrons, gold on its own, 0. Okay? Oxygen on its own, 0. Now, sodium we know is +1. This ion then, the cyanide ion, must be a total of -1. Let's just recognize that it's also sitting over here. So I don't need to go into detail. Sodium we know is +1. There are 2 of those, so that's -2. So gold here is +1, because if I add up those totals, +1 + 1 -2 will give me the total of 0. And that's exactly where we are. Oxygen there is 0. The oxygen there is -2. The only oxygen here is -2. So this oxygen has gone from 0 to -2, and this gold has gone from 0 to +1. So I hope you can see that there's been a transfer of electrons. And in fact, we can say from 0 to +1 is a loss of electrons. So that means that this is the oxidation reaction. And that means that that is the reducing agent. And oxygen has gained electrons. It went from, so this is the gain. So this is reduction. And we can therefore say that that's your oxidizing agent. Remember, oxidizing agents take electrons, reducing agents donate electrons. Okay, guys, the last part of this question said, will the solution formed during the process be neutral or basic? Refer to the equation. Well, we saw there was some sodium hydroxide. So I'm going to say that it's basic because of the sodium hydroxide present. Okay, got it. Well, that leaves us with the challenge question. How are we doing with that? Let's have a look at the first part. And now you'll perhaps understand why I wanted to do the one with gold. What type of reaction is this? Well, here's the clue. Whenever you're given a reaction, if you see that you've got a compound and you've got an element of that same that's present in the compound on its own, then it's likely that there's a redox reaction. So what do we see? Here's iron on its own, oxidation state 0. Iron over here, let's work out its individual oxidation number. -2 times 3 is -6, plus 6 divided by 2 is +3. So that's iron 3 has gone from, iron has gone from an oxidation number of +3 to 0. What is that? That's the gain of electrons. Agree? It's gain of electrons, which means that this is the oxidizing agent. The oxidizing agent has taken. What about this situation? -2 means that's +2, carbon in the +2 valency, +2, not +4. And over here, -2, -4, +4, +4. So it's gone from plus, now I need to really erase that, just so that we're very clear that this is carbon monoxide +2, and it's gone from +2 to +4. What's that? That's the loss of electrons, which is oxidation. So that means that this substance here, the carbon monoxide, is the reducing agent. Now, you weren't asked to do all of that, but I just wanted to revise it so you're very clear in identifying, yes, that this is a redox reaction. Now, the last part, which is the part that I know that some of you may hate, but some of you will love, is to do some chemical calculations. Remember, just because we're doing mining doesn't mean that you forget all your other chemistry. This applies to both grade 11 and grade 12. You can get integration of questions. So let's have a look at this particular question. It tells us that 0,752 kilograms, a sample of ore, produces only 365 grams of iron. What is the percentage purity of the ore in terms of the iron oxide? Okay, so first step that I'm going to do is I'm going to refer up to that balanced equation. So I'm going to rewrite the balanced equation. Fe2O3 plus 3CO gives me 2Fe plus 3CO2. Now, what I need to do, the first thing I'm going to recognize is that there's a ratio of reacting moles. 2 moles of iron is formed from 1 mole of iron oxide. be very careful that this is the ratio that we need to deal with. We're not worried about the carbon monoxide or the carbon dioxide, but we need to, from the balanced equation, identify the balancing coefficients and recognize there's a ratio of 1:2. The next step is to say, how many moles of iron have I got? So I'm going to say the number of moles of iron is equal to the mass of iron given divided by the molar mass. Now, on the periodic table, the relative atomic mass of iron is given as 56 grams per mole. So I'm going to put that in and say we've got 365 grams divided by 56 grams. And notice this is grams. So on my calculator, I must make sure all my units are correct. And I'm going to say 365 divided by 56, and it will give me an answer of 6,52 moles. 6,52 moles. Now, guys, there's just a point here. Some of you will say, but we were given kilograms. Guys, in chemistry, the SI unit for mass is grams. In physics, it's kilograms. So make sure that you're working in grams when you're doing chemical calculations, particularly from the periodic table. So because of this ratio of 2:1, I can now say the number of moles of iron 3 oxide, Fe2CO3, is going to be half the number of moles. It's not going to be 1:1 ratio. It's going to be 6,52 divided by 2 because of the ratio, and that gives me an answer. Let's pick it up on the periodic on the calculator. Divide by 2. I should actually, no, let me do this properly. I must round off. 6,52 divide by 2, and I'm going to get an answer of 3,26. So make sure that when you do this, 3,26, you take your rounded answer, put the rounded answer into the calculator, and then work it out. So we now know that the number of moles of the iron oxide is 3,26. How are we going to work out the mass? So the mass is equal to, using the same equation, is equal to the number of moles times the molar mass. In this case, it's going to be 3,26 multiplied by, in brackets here, 56 times 2 plus 16 times 3. Now I'm going to put that onto the calculator, and let's see how we go. Keep that answer because that's 3,26. I'm going to multiply the answer in brackets by 56 times 2 plus 16 times 3. I got the 16 from the periodic table for oxygen, and I say that's equal to a mass of 521,6. 521,6. Let's write that down. 521,6. But that's grams. Now, the final part is my percentage purity of the Fe2O3 is going to be 521 divided by my mass of my sample. And what was the mass of the sample? Look what it said. 0,52 kilograms. So that's 752 grams. 752 grams. And simply taking my answer, divide that by 752 times 100 to give me a percentage. And what does it turn out to be? 69,36, and that's good enough, will equal times 100 over 1 gives me 69,36%. Tell you what, miners would really like to get hold of that all, because to get 69, almost 70% purity would be amazing. It would be really rich. Some mines, iron mines and gold mines, are operating on ore that is less than 25%, even 15% purity. So it's actually quite a lot of work to get back. Tara, are there any questions?
There aren't any questions. I did get
Okay,
a lot of
that's
responses, though, while you were doing it, and a lot of them were right, so well done for that.
Excellent. So, guys, I hope you've enjoyed this session, and I really want to ask you to study hard. Remember to refer to the Learn Extra notes, and don't forget, we'll be with you for exam revision, which is coming up next week. Last words from you, Tara?
Yes, definitely. So don't forget about the exam revision. It's getting so close, and it's that 10th time of year, but we know you can get through it. Don't forget about all the other awesome competitions that we've got running at the moment, so you could win from cars to calculators to cell phones by entering competitions, testing yourself, seeing where you stand. It's all very important stuff for yourself, as well as giving you the opportunity to win awesome prizes. And lastly, don't forget about the really cool event that we've got going this weekend, Saturday and Sunday at the Kyalami racetrack. I think it's going to be absolutely incredible, and I can't wait to hear and see what everyone will come up with and see how efficient our youth is at coming up with these ideas to make this the future a greener place. So definitely pull through. Once again, it's for free, but we'll hopefully see you there.
One last thing. Remember to tune in for the parallel parking clip for the K53. From me and Tara, great to have been with you. Goodbye.
Thank you very much. Goodbye, guys.